Okay, power of a function rule. So similar to our rule we just went over, which was our product rule. Only difference is now, imagine we have a function. So f at x is equal to some function raised to some power. Okay. Like the product rule, when we go to find a derivative of this, it's almost like we prime one and stay with the original, and then we prime the other. So the idea is we take our n, or our exponent, it now becomes a constant or coefficient in front. We still leave the original whatever's in the brackets, and that is now raised to n minus 1, so our new exponent. And then we have to multiply it by the derivative of what was in those brackets. Okay? So somewhat similar to the product rule. Let's go over an actual example here. Example 5 in your book is written as h at x is equal to x squared plus 3 at x plus 5 to the power of 6. So, and they ask us, please find h prime x. Well, I wanted to bring your attention. Think of what's inside these brackets. I'm going to highlight it in green. These inside of the brackets, these are our g at x. Okay? Thank you. So that's going to be our g at x. And our n is the 6 here. So this is our n part of the function. This is our g at x part of the function. Okay. So the n is going to have to be brought down, and we're going to left with the original. Then we're going to have to find g prime, what was in those brackets. So h prime x is going to be equal to, we bring the 6 down in front. We leave what was already in those brackets the same, x squared plus 3x plus 5. And we subtract the exponent by 1. So it used to be 6 and now it becomes the number 5. Okay. So if you notice, we still have our g at x inside the brackets. Next, we'll have to find g prime x, though. So we're then going to multiply it by the derivative of what's inside the brackets. Well, inside the brackets, if we derive this, we get 2x plus 3. 5 is a constant, so its derivative is 0. So there's our g prime x. Okay. So we've now gone about that part of the question. And that's it. We could expand and simplify, but this is probably a simplified version. Expanding this will make this a very, very large question, okay? Especially since this base is raised to the 5th power. Expanding and simplifying will take us a very long time, so we're going to leave it like this because we know we can plug in some value of x. Did they actually give us a value in this question? No. And then just plug it into this specific equation to find h prime x. So that's all there is to it.